Hello and welcome to yet another edition of Brain Maths. On today's edition, we want to look at simultaneous linear equations. As the name implies, linear equation. If you look at what we have here, you'll see that the highest power in each of these equation variables are 1. The highest power of x here is 1. The highest power of y both in the two equations are 1. So we are going to try to solve these equations simultaneously. But before we go to solving the equations, there are two major methods for solving simultaneous linear equation. Apart from the graphical solution, we have the elimination method, which we are going to look at firstly, and then we have the substitution method. So by the method of elimination, from the name elimination, it means we are going to try to find a way to eliminate either of these variables, either to eliminate x or to eliminate y. And if you look at what we have here, this is the simplest of all simultaneous linear equations, in the sense that the highest value of x and y, as said earlier, are 1, and the coefficients of x in the two equations are also 1. So it is easier for us to eliminate x than eliminate y. So we have to look for a certain sign that will put between these two equations to make x approach 0. How do we make x to become 0? So if we say x plus x, that is going to increase the number of value of x. That is going to give us 2x. But if we bring minus here and we say x minus x, that is actually going to give us 0. So in that case, we subtract, and the solution is going to look like this. X minus x is 0. 2y minus 3y, that is going to give us minus y, which is equal to 5 minus 8, and that is also equals to minus 3. So there is a negative in the value of our y, so we multiply through by minus. Minus times minus will give us plus, and that is y, and minus times minus on the other side will also give us plus. So our y equals 3. So this value of y will now be substituted into any of the two equations. Note, any of the two equations. If you put the value of y in equation 1, the answer you get will be the same as when you put the value of y in equation 2. So we say substitute y equals 3 in equation 1. So we have x plus 2y equals 5. When you put y in its place, we have x plus 2 into 3 equals 5. 2 times 3 is going to give us 6. So we have x plus 6 equals 5. And from what we are seeing here, we can easily take plus 6 to the other side by collecting like times. So we say x equals 5 minus 6. Therefore, our x equals to minus 1. So therefore, the value of x is minus 1 and the value of y is 3. Let's try to look at another question where we are not going to have a uniform coefficient as we have seen in the previous question. So in this question, you will see that the coefficients of P and the coefficients of Q are not uniform. In the previous one, we had coefficients of X to be uniform, but here now, we have 3P and 4Q. it is not easy for us to eliminate any of these variables. So in that case, we have to decide which one we are eliminating. If you are eliminating Q, you have to multiply all the questions in number one, equation one rather, by the coefficient of Q in equation two. And if you are doing that, then the same thing has to be applied to the equation 2 by multiplying that equation by 2. So let's try to eliminate Q. So we have multiply by 3 the coefficient of Q in equation 2, and then we multiply equation 2 by 2, which is the coefficient of Q in equation 1. So this is going to give us 3 times 3p, that is 9p, plus 3 times 2, 6q, equals 3 times this, 21, equation 3, and 2 times 4, 8p, plus 6q, which is equal to 20, equation 4. Now, if you look at this equation now, we have seen that the coefficients of q are now uniform. So it is easy for us to eliminate q. So which sign are we using to eliminate q is the next question. So we have a positive here and a positive here. If we put positive, then these two will become plus 12. But if we introduce a negative sign, we are only concerned with q. Whatever happens to the other ones remains. But we have to find a way to eliminate q. So in that case, we are going to use negative, and that is going to give us 0 on this side. So we say 9p minus 8p, that is p, which is 1p, and 6q minus 6q is going to give us 0, equals 21 minus 21. So therefore, our p equals 1. So we have to substitute the value we have gotten into any of the two equations given to us, either equation 1 or equation 2. So let's substitute into equation 2 this time. So we have 4p plus 3q equals 10. So anywhere we see p, we change it to 1. So we have 4 times 1 plus 3q equals 10. That is going to give us 4 plus 3q equals 10. So the next thing is to collect like times. The positive 4 will go to the other side and become negative. So we have 3q, which is left on this side, equals 10 minus 4. So our 3q becomes 6. We are looking for the value of q. So we divide both sides by 3, which is the coefficient of q, and q equals to 2. So therefore, our p equals to 1 and q equals 2. I'm going to leave you with these two questions on the board. Solve the two questions by elimination method. Try to find a way to eliminate either of these variables and come up with a solution. Don't forget to subscribe to this channel if you have not done so. Until I come your way next time, have a nice day.